Recording. Yo, I'm recording.
Ladies and gentlemen, get ready to test your skills and compete for incredible prizes. This is the ultimate game show where contestants will face challenges like never before. It's time to buckle up and show us what you're made of. Welcome to the show, everyone. So I would like to introduce my contestants. In the black hoodie, we have Aryan, and in the red maroon shirt, we have Ethan. So let's get started here. So can someone tell me, Aryan tell me what intermolecular forces are?
Intermolecular forces are like a type of force.
So the correct answer is that intermolecular forces are the forces that hold atoms together within a molecule, such as a covalent and ionic bond. Intermolecular forces are the forces between molecules, such as hydrogen bonding dipole-dipole interactions and van der Waals forces. Intramolecular forces are generally stronger than intermolecular forces because they involve the sharing or transfer of electrons, which require more energy to break. So,
Man, how did I know that one?
Ethan, could you tell me how 3 types of intermolecular forces are?
The intermolecular forces, they're dipole something, hydrogen something, and I think that's it.
So the correct answer to that is that that is actually incorrect. So the 3 types of intermolecular forces would be London dispersal forces, dipole-dipole forces, and hydrogen bonding. London dispersal forces are present in all molecules and are caused by temporarily dipoles. Dipole-dipole forces occur between molecules with permanent dipoles, and hydrogen bonding occurs between molecules with a hydrogen atom bonded to a highly electronegative atom like oxygen or nitrogen. Arden, can you tell me the properties of solid, liquid, and gas?
For a liquid, water's wet. For a gas, it's a gas, and then for a solid, if you punch it hurts your hand.
So that's actually incorrect. So, solids have a distinct volume and form. They have powerful intermolecular interactions that keep the particle in place, creating a hard structure. Although they take on the shape of their container, liquids have specific capacity. Liquids can flow because of lesser intermolecular interactions with solids, which enable particles to pass one another. Gases don't have a distinct shape or volume. They completely occupy the available area due to their extreme compressibility. Gas partners move randomly and quickly, hitting one another and container walls due to weak intermolecular forces. Ethan, can you tell me changes of state or matter?
State of matter. The state of something like Kentucky or Texas, and the matter is something that matters to it.
So that's actually not correct. So the correct answer is that thermal energy variations are what causes changing state of matter. Melting can occur when thermal energy increases, as does vaporization when thermal energy increases from liquid to gas. Condensation and solidification are 2 processes that can happen as a result of thermal energy decreasing from gas to liquid and from liquid to solid. Arden, can you tell me what water phase graph is?
A water phase graph, it has water and it goes through things.
Is there anything else you would like to add on to that?
Nah, I'm 100% right.
Alright, let's see. So the water phase graph shows the physical state of water, solid, liquid, and gas, vary with changes in temperature and pressure. The graph demonstrates that water may persist as ice as low pressures and temperature. At the melting point, it changes from solid to a liquid as the temperature rises. Water exists in a liquid form when temperature rises. Water changes its phase from a liquid to a gas at the boiling point. The graph also shows the critical point, which is the point at which water loses its exists as a distinct liquid or gas phase, and the distinctions between its many forms, solid, liquid, liquid, gas, they all become hazy. Ethan, can you tell me what specific heat is?
It's something that's specific to how warm that item is. Like, say, like a pot of pasta. That's warm, right? So that's specific to that heat. You know what I'm saying? How do I get that wrong, man? You know, pasta's hot.
Alright, so specific heat is the amount of energy required to raise the temperature of a substance by 1 degree Celsius or 1 Kelvin per unit of mass. In other words, it is the amount of heat energy required to increase the temperature of a unit mass of a substance by a given amount. Can you explain to me what energy is?
Energy is like the energy that you need to do things that require energy.
That's actually incorrect. So, the energy of IMF refers to the potential energy stored with the interaction between molecules or atoms due to these forces. When molecules or atoms are attracted to each other by IMF, they are in a low energy state when they are far apart. Conversely, when molecules or atoms are repelled by each other, IMF, they are in a higher energy state when they are far apart. Ethan, could you explain to me what freezing point is?
Something like, when it's cold, it gets like really cold, and that cold makes it cold. Like, it's like an ice cube.
I mean, you got the right idea, but that's not quite the definition. So the definition is the freezing point is the temperature at which a substance changes from a liquid phase to a solid phase under the normal atmospheric pressure. It is the temperature at which the solid and liquid phases of a substance coexist in thermodynamic equilibrium. The freezing point of a substance is the characteristic property that depends on the substance's chemical nature and external conditions, such as pressures and impurities. For example, the freezing point of water at standard atmospheric pressure is 0 degrees Celsius or 32 degrees Celsius. Aaron, can you explain to me what boiling point is?
It's like the amount of heat it takes for me to like melt and like turn into a puddle.
So you have the right idea, but that's not quite the answer. So the melting point is the temperature at which a solid substance changes from its solid phase to its liquid phase under normal atmospheric pressure. It is the temperature at which the solid and liquid phases of a substance coexist in thermodynamic equilibrium. The melting point of a substance is a characteristic property that depends on the substance's chemical nature and external conditions, such as the pressure and impurities. For example, the melting point of water at standard atmospheric pressure is 0 degrees Celsius or 32 degrees Fahrenheit, which is also its freezing point. And that will be it for today's game show. So I want to give a round of applause for all the contestants playing. And also, I just want to say, how did you guys not know any of the answers to anything?
Wasn't this like, what kind of talk show was this supposed to be? Because like I was told something different.
You do realize that this is a chemistry game show, right?
I wasn't paid enough to know this.
Okay.
Alright.
Alright.
Well,
I'm out.
good job, guys.